make the big bucks, get good at coding, then go on a lot of vacations. It's the path, right? What was the homework? Remove it index?
Yeah.
Oh yeah, I need to ask you a question after that too, because there's two code. One of them work and one of them don't. And
So it's not a question. That's your self-evaluation. Half of what I turned in was crap. The other half was okay.
No.
Here's a cricket in a box. Was it a cricket? What was it?
It
It was a cricket.
Oh yeah, I emailed you on Slack. And
You emailed me a cricket in a box on Slack?
No.
You don't email on Slack.
Oh, I text you on Slack.
Is even text accurate, or is it I slacked you?
I would say message.
Huh? Message me on Slack. Yeah. I totally slacked a former student the other day. It was really funny too. He it was a slap, but he turned into it to just the perfect timing, right? So I was going to fake it, right? And my wedding ring. Oh, I mean, this was a 4.5 out of 5 full contact. He's like, "Is there a mark?" It was. I thought it was hilarious.
Broken your bones?
I hope so. Because he'll have time to heal. I'm going to Mexico with him next month.
Oh my god.
The tan will cover that up.
Huh?
The tan will cover that up.
Seriously.
Bring some beer. Protect your face.
And then I'm going on a 2-week cruise out of Copenhagen in May. This should just be an advertisement for coding people. Codes spend 4 months per year somewhere else.
Well, it's also not my strength, so I want to use my strength.
But it can be. You're good at it. I've told you multiple times you're good
In
at
the
it.
summer, it was really bad. That was funny.
You're good at it. You just have this perception that you're behind everyone else when everybody sucks and you get the right answer way more often than most of them do. You're supposed to go through hell until you get good at it. Then all of a sudden you look back and say, I cannot believe I spent 30 hours on that. When now I can write it in 15 minutes while I'm watching episode 4 of my favorite show.
That's true.
You'll get there. You just gotta believe in the process. It's not magic.
No, you said programming is a whole bunch of magic tricks put together.
Well, that's how CPUs understand, yeah. No, what I do is magic. What you do is something else. It is something else. This reminds me of merge sort.
Yeah, bubble sort 370.
What is that?
I sort of actually teach a modified, my insertion sort I teach is kind of a modified bubble sort where things bubble towards the top. I like that algorithm better. Plus, my favorite variable of all time is the follower. Mm-hmm. Remember the follower? I put the little skull guy on there. Love the follower. Is that it?
I just remembered that when I watched the video
And you guys said the follower follows.
I listened to that like 3 times. I'm just like, oh my gosh. You're in the fast mode? What? Was it in the fast mode?
The follower follows.
I definitely,
We already have a link list thing here, right?
like recently, whatever I listened to, was like people talk so slow.
Well, hold on. We've been doing this in Android Studio. We've been doing this in Android Studio. Okay, why am I in Eclipse then?
Because you didn't pay attention to us. Rather shame.
Is this us? Patient record?
Yep.
All right. So we are supposed to write remove end and then remove an index. Okay. And I assume both of these were pretty easy? So public int remove end. So we can cheat a little bit, right? Actually, we don't even need to cheat for it. So let's look at our picture. This, what class is this? This one?
300.
Oh, look at that. I'm so good at pictures. We don't think I'm good at pictures? Look how beautiful this is.
After the commons, you're pretty good.
Well, the guy at the Commons was solid. Not at the beginning, but he started doing 3D dry erase board art. Yeah, we were at this incubator thing from the National Science Foundation that Blaine and Austin are involved in, because they've worked really hard at coding. And and so I'm sitting there drinking my coffee and grading because I somehow got sucked into this thing, and I'm the driver. So this guy's doing like their whole project, like kind of building out a business model and stuff like that on this dry erase board. And he's pretty organized, looks like he's done this before, but then he starts drawing like arrows that are in like 3 dimensions. Why is that even necessary?
It was cool.
But it did look cool in the end. They were all impressed early on. I was not impressed early on, but towards the end, like, this is bad. I took a panoramic picture of it. And that's pretty good because I only take pictures of food or Mr. Gonzalez, those 2 things. All right, so for remove end, we're going to need to move to the thing right before the last thing, right? All right, so that means I need at least a to list in order to do this conveniently, correct? So if I have a 1 list or less, we didn't do error checking last time, right? Okay, we're not doing any error checking. So if I only have a 1 list, which means you would not call remove end on an empty list, then I can go ahead and call remove front, because we wrote that already. Mm-hmm. All right. How do I ask if I have a 1 list? How do I ask that question? Do I have a 1 list? If who?
If head equals null.
If head equals null means I have an empty list. How do I ask if I have a 1 list?
Head.next node equals null.
Okay, you can ask it that way. You can say if this dot head dot get next node is equal to null, then we'll call return this dot remove front. Can we ask this in any different way? Don't overthink it. Go ahead.
Count equals 1.
Count equals 1. If you have a 1 list, what does that mean? You got 1 thing in your list. Do we have a variable that keeps track of how many things we have in our list? Yeah. If this dot count is equal to 1, go ahead and call remove front. Right? Now, the other one was fine, but that's real easy to understand, right? I have a 1 list. Call remove front. Okay, otherwise, must have at least 2 thingies. Thingies apostrophe? No.
I'm missing an
I think it's IES.
Missing an A?
A.
All right. Must have at least the last. I can't pronounce that. We need more E's. All right, so must have at least 2 things, thingies. Put all the superpowers into coding. I can't spell. All right, so must have at least 2 thingies in our list. So what do we need to do? We need to position ourselves at the thingy right before the last thingy. Okay, node right before the last node. So now we go back to our picture here. So I'm going to need a variable to point at the beginning of the list because we're not changing head, right? And then I need to walk that guy from node to node to node to node until what happens? Until I have a next node whose next node is null. Or what? How many steps? So this, what's the count of this list right here? This list has in my current example has a list of 4, and I need to take 1, 2 steps to get to the guy right before the end. Count minus 2. That's the number of steps I need to take because I want to be at the guy right before the last guy. And the last guy, since I'm operating off of a 0 index, is actually a bucket length minus 1. So I need to take count minus 2 steps. So if it was a 4 list, I'm going to take 1, 2. If it was a 3 list, I'm going to take 1. If it was a 2 list, I'm going to take 0 steps. So I know exactly how many steps I need to take, correct? I need to take count minus 2 steps. When you know exactly how many times you need to repeat something, what's the right tool for the job? For loop. So we'll say node cur node is equal to this dot head. And we'll say a little for loop for int I is equal to 0. I is less than this dot count minus 1. Actually, it'll be minus 2 here because we're going off of 0. So if this dot count is 4, it'll be 0, 1, 2. No, it's less than 1. So if count was 4, we want to get to I is equal, we want to go through this twice. So is 0 less than 3? Yes, it is. Is 1 less than 3? Yes, it is. It actually is minus 2. All right, this is the number of steps we have to take, and each time through we'll say cur node is equal to cur node dot get next node. So now we are positioned at the element right before the one we want to remove, which happens to be the last node. Make sense? All right, but now we need to do surgery. So come back here. So if I am removing, in this case I am removing end. In a few minutes we're going to be removing at index, but I'm removing end here. So we have a 4 list, so I take 2 steps. I'm here, then I'm here, then I'm here. Okay, so I'm sitting right here. So what do I need to do? This is the guy I'm ultimately going to return, correct? I'm going to return his payload. Now, I can't disconnect him yet, otherwise we lose it. So I need something that's going to point to this guy. So we'll do like a node to return is equal to cur node dot get next node. So I'll point at that dude. So did I have that variable last time? We'll just use this then. Node to return. So I have a variable called node to return. I'll go ahead and point him at the same thing as cur node's next node points to. All right. Then I can go ahead and disconnect cur node's next node. Cur node dot set next node to null. So that does that. All right. And then the final guy I want to return is the payload of node to return. Return cur node dot get payload. Now, we do need to remember, up here when we called remove front, that guy is going to decrement count for us, right? Let's check to make sure we did that. Yep. So remove front decremented count. In this case, in the else, we did the removing. So we need to make sure we say there is one less thing in our list now. We decrement count. Go ahead.
Why don't we return node to return?
Aren't I returning? Oh, we do. Thank you. Node to returns payload. What my picture says. This guy's payload.
Question.
Mm-hmm.
Where is that note to return get payload, like where is it stored at? Because I was
Right
just
here.
trying to look at.
I set node to return equal to cur node's next node.
But the reason why it's not on the screen because I didn't print it out, right?
Well, I'm not printing it, but this is what my list looked like before. My list looked like that, right? I ran cur node up to the guy right before the end of the list. So that's this guy right here. Then I created a brand new variable called node to return, and I pointed him at cur node's next node. That's where node to return gets his value, right? Presumably he's there because we added something, as we built our list up, we have at some point added a 3 that ended up at the end of the list. Whether we added it at the end or kept adding things in front of it, however it ended up getting there. So node to return points at the node that is at the end of the list. So we've just given a name to that guy. Then we disconnect. Then we decrement count because now there's one less thing in our list, and we return this dude's payload. All right, so that should be remove end. So we can test that. Do I have test code in here? Yes, I do. So let's see what our list looks like right now. All right, so this is our list right now. If I call remove end, that 33 should be gone. So if I say system.out.println ll.remove end, it'll print out a 33. Then I display it. We should have that same list without the 33 on it. There's the list without the 33. Where did I put? Oh, I didn't put the little asterisk in front of him, so he's not in my filter. I promise you he's in there. All right. Make sense? And everybody gets that. That's why I'm putting asterisks in front of everything. So I can conveniently pick it out of my verbose output, because if I don't search for this, there's a lot of crap in here. So by me purposely putting a couple of asterisks before I print stuff, I'm able to filter on that right here and see my stuff more easily for testing. Get it? All right, so that's remove end. Easy enough?
I have a question.
No.
Please. So, like, usually, like, when you add, like, ll.remove, like, if it's outside, I understand that, like, it will have an effect on the list, but right now, like, you put it inside with the string. How does that affect the list?
What do you mean I put it inside with the string? Like right here?
Yeah.
Well,
How is that line?
because this part right here. That guy right there actually does remove the element from the list, and this guy will boil down to the number that we removed. And then I'm just concatenating him onto that string. I'm not using him for anything else. If I wanted to put him in a variable and then use that variable in here, that'll give me the same output. Now I can use that value I just removed later on because I stored it somewhere. Where before I was just using it directly. I was just saying, look, I'm going to get this guy off the end of the list. I'm not going to use him again, but I'll prove to you I got it by just printing it out. Because any way you cut it, this guy right here boils down to the integer that we just removed from the list. Because that's what remove end returns. If we look at our linked list here, remove end returns an integer. What integer? The payload of the node we're going to return. Make sense? Oh, good announcement. Our very own V was nominated for Student of the Month. She lost,
Oh, V.
but got third place. Don't ask me how many people there were. That is quite an accomplishment. She had many, many, many votes. So that was a,
Like in the department?
well, no, whole school.
Are you serious?
Yeah, I mean, yeah, this is the entire university.
Because I don't know anyone.
That's why you got third. No, but you got significantly more votes than there are people in the department.
That's good news.
Well, maybe they just voted for the weird name. No, very deserving. I think she deserved to win, but that's because I didn't know the other people. Well, we've had a lot of computer science people recently. We had last month, Grace Coaster did win. November, Maddie Martins did win. Blaine's been nominated, also lost.
Thank you. You work hard enough on that one. You can pull strings, can't you?
Dr. Locklear, he's the one that gets accumulates all the votes.
Mhm.
He runs the student of the month thing. So he puts out, here are the nominees, and then all the faculty vote either electronically or they can reply to it. So I mean,
So,
votes could possibly be skewed depending on where you think his ethics are, and then the amount of money it takes to make that break.
I guess.
The amount of, yeah.
I
What's
mean,
this?
Is it being stored on his?
I mean, I think he's manually doing the count. Yeah, I don't think it's like a super. I mean, he gets either like a survey reply, and then he gets emails like, "I vote for blah. I vote for blah." The dean of the business school is calling me. Put him to voicemail. Answer the phone. Yo, put him on speakerphone. All right. So, makes sense for remove end. So let's look now at remove at index, which is actually fairly similar to remove end, right? You do a lot of the same moves. All right. So, where am I? Where's my linked list? So public int remove at index, and we'll take in an index for the guy we're removing. Okay. Now, we need to remove that element from that index. If the index is 1, what can we do? Well, actually, if the index is 0, we're removing front, correct? So if index is equal to 0, return this dot remove front. Else if the index is equal to, what's the last legal index? Count minus 1. Return this dot remove end. Else, it's somewhere in the middle. All right, Midley. It's a Game of Thrones type of twist on how to say that name. It's an old Dark Age thing. I actually don't think they ever said Midley. Probably need to keep that. Midladley. That's how you say it. All right. So it's somewhere in the middle. So if it's somewhere in the middle and we want to remove something, so we go back to our picture here. I'll just reconnect my list so I have 4 elements. All right. So if it's somewhere in the middle, that means we're removing either this guy or this guy in my current example, right? I have a 4 list. I'm not removing bucket 0 because if I was doing that, I'm calling remove front. I'm not removing bucket 3 because if I was doing that, I'd call remove end. So I must be removing bucket 1 or 2. Make sense? All right. So if I want to remove this guy, I need to get to the guy right before him. If I want to remove this guy, I need to get to the guy right before him. So if I'm removing bucket 1, I want to get to bucket 0. If I'm removing bucket 2, I want to get to bucket 1. So on and so forth. I need to position myself at the guy right next to him. All right? So if this guy is bucket 1, if that's the index I'm removing, I want to take 0 steps. So I know exactly how many things I need to go. I need to say count. I need to say I equals 0. I is less than count minus 1. That will take me up to the guy right before the dude I'm removing. For its I is equal to 0. Keep going as long as I is less than this dot. Actually, it's not count minus 1. It's index minus 1. I plus plus, right? So if index was bucket 1, I'm going to start at 0. I'm going to say, is 0 less than 0? It's not. I'm already where I belong. Where's that picture? That's if I need to build in my Kernode guy here. If I was at 0 and I'm removing this guy right here, I ultimately want to point right here. I actually don't want to take any steps. So I will start off at 0. Is 0 less than index minus 1? Index is 1. 1 minus 1 is 0. Is 0 less than 0? It's not. We won't take any steps, which is exactly what we want. If it was a 2, is 0 less than 1? It is. Take 1 step. Is 1 less than 1? Nope. We're done. We've positioned ourselves where we want to be positioned. So I'm going to need to have my node, Kernode, and this guy will start off at this dot head. Then we'll zip him up to where he needs to be. Kernode is equal to Kernode.getNextNode. So right now, Kernode is positioned right before node index. Right? So we have this picture. Here's my where am I? Kernode. Kernode's, assuming index was 2 that we're returning, we're positioned at bucket 1 right now. Now the guy we're going to return, we want to keep track of him. So we're going to say node to return is equal to Kernode.getNextNode. Right? That's the guy we're going to disconnect. And we're kind of doing surgery now. How many of you, as you were going through this, kind of thought about that, like we're doing surgery, kind of almost like removing an appendix or something? Yeah, because I mean, after you take something out, you want to tie up those loose ends, otherwise the person dies, right? Which is only funny 3 or 4 times. But well, in linked list lingo, if it's like people and stuff, it's only funny like twice. So what was I talking about? Oh, people dying. Okay, so so we're going to have our node to return be the guy we're actually going to be removing. So we'll go ahead and we're going to say we have a node to return, give ourselves a little variable, and the guy we're ultimately going to return is Kernode.getNextNode. Right? That's the guy we're going to ultimately return. Now, before we can return him, we need to disconnect him. So I need Kernode's next node to be equal to node to returns next node. Right? So I need to disconnect this. So wherever Kernode points, he no longer is going to point to node to return. I now need him to point to the same place that node to returns node points to. Make sense? That might be out to nowhere. That might be null. If he's the second to last. Actually, it would never be out to null in our case here. But it doesn't matter. It doesn't change our code. Okay, so I'm going to set Kernode.setNextNode to node to return dot get next node. Kernode.setNextNode to node to return dot get next node. That does this. So we set Kernode that used to point here, we set his next node to the same place that node to return, which is this guy right here, points to. So that does that. Then we finish cutting out node to return. So we set his next node to null, right? Node to return dot set next node to null. So now this guy is free and clear, and our list is still in. It's in order. We've reconnected everything we needed to reconnect. We still have access to this disconnected node through this pointer called node to return. He's pretty integral to this whole thing. We needed him so we didn't lose track of these things, right? Okay, so we're ready to return this guy, but we have a couple of housekeeping issues to do. We have to reduce the number of elements that are in our list. So we're going to do count minus minus. All right, because we did just remove something. So this dot count minus minus, one less thing in our list. And then finally, we will return node to return dot get payload. And that's what remove at index will do.
Okay, so I wrote node to return dot, for example, I'm saying node to return dot get next node dot get next node. Do you know why it doesn't work?
You said node to return, so you returned.
Like the kernel. For example, like if I don't have the node to return thing, I'm just saying kernel dot get next node dot get next node like 2 times. You know what I'm saying?
Well, yeah,
That line
because
doesn't work.
no, I get it. Well, but did you do all the other rehookup stuff? See, follow it this way.
Because I mean that's why it doesn't work for my kernel.
Yeah, but watch this. So here's your cur node, right? Cur node used to point here, right? Cur node's node used to point to this next guy. So you would say, I want to return cur node dot get next node dot get next node. Okay, that would return this guy here, which is the wrong guy. But in this particular example, it wouldn't have given you an error. It just would have given you the wrong guy. But after you had updated cur node's next node to here, you would have said cur node dot get next node dot get next node, which would be null. Because now you have your cur node's next node being this moving target. It used to be this guy, now it's this guy. That make sense?
Okay, so basically I can put it like on the same line without any arrow. Is that what you're saying?
Well, if you're gonna if ultimately you wanted to get to this guy, you could say cur node dot get next node dot get next node, and that will give you this guy. As long as you did that before you changed cur node's next node. If you change cur node's next node to cur node's next node, now cur node's next node is nothing. Because cur node is moving along our list. So you just got to make sure that when you are asking for his next node, he hasn't already shifted one extra element down the list where now his next node might be nothingness. Okay, get a point here, the point here. Okay. So that is our code for remove at index. We go back to our test here. Let's see, we have, we can remove an index 1, get rid of that 2. Where's my on create? So if I say remove at index 1, that'll give me the 2. So that'll print out a 2. Then, here I'll put a couple of displays in here. ll.display. So that'll be after we remove the end, and then I'll do an ll.display, and that'll be after we remove the 2. We dump this, hit play. So here is our remove from end, 33 is gone. Here is our remove at bucket 1. That gives us, oh, I actually have 2 displays here. That's why it's showing up twice. So my 2 is gone. If I say remove at index 2, it would actually be the 13 that goes away. So there's my 13 we disconnected, and it's gone now, so on and so forth. Make sense? All right, so that is remove at index. Not too bad. But you see how vital it is that you draw the pictures? You didn't draw the pictures, you're just guessing. And the order might be, you might break by doing things in the wrong order. All right, so let's go ahead and get this pushed up to GitHub. Added, remove end, and remove add index to linked list. We will commit and push. Okay, and call that perfection, right? No harm, no foul. All right, so let's pause from this for, well, before I pause from this for a minute, why is it that we did linked lists at this point in time? What problem is linked list going to help us solve based on what we've been doing up to this point? That's the problem linked list in general solves, is it saves us memory at the cost of speed. Go ahead.
We don't need to know how many values.
Yeah, so up to this point, we've been storing, for your assignments, you've been storing 1,000 basketball players. And in my version, we've been storing 1,000 patient records, right? Just because, well, we just gave ourselves a big enough trough to hold all the basketball players or patient records we might ever have, hoping it never goes above 1,000, right? But then what we had to do is we had to pre-fill that guy with a bunch of stuff to hold those elements, right? And then we had a whole bunch of kind of dummy elements. Well, now we have a new collection type that's going to allow us to store 0 or more basketball players or 0 or more patient records. Almost. The difference here being is we currently have a linked list that can hold integers. What we really need is a linked list that can hold basketball players or patient records. That make sense? So I need a linked list that can hold a different type of element rather than an int if I want it to work for our application here. Okay? So we're going to come back to that. Now, the structure of the linked list isn't going to change. What's really going to change is node will no longer hold an int payload, now it will hold a basketball player payload, which will then modify all of these things where like remove end will return a basketball player. Remove at index will return a basketball player. Remove front, basketball player. Get at index, basketball player. Add at index, here's the value we're adding. The value we're adding will be a basketball player. Basketball player. Basketball player. Make sense? All right, similarly here, when you do your display, rather than just saying get payload, which is a basketball player, you might have like a get basketball player .toString or something like that to give you like a string representation of him for testing. Okay, because payload is not just an int. If I just have a normal plain Jane basketball player and I haven't written my own toString, I'm just going to get a bunch of memory addresses. It'll look fancy, and they'll be unique memory addresses, but it'll be a bunch of memory addresses. All right. So before we tackle that, let's go through the slides up to this point. We do have our midterm on Thursday. So let's talk about what I think is important and what still might be on there. I'll try to tell you what might, I haven't written it yet. All right, so definitely something I'm going to test again because it didn't test well at the end of 250. That's why we covered it so heavily at the beginning of this semester, is this idea of creating your own objects. So you will almost certainly, I'll almost certainly on the exam give you a scenario where, you know, we're keeping track of musicians, where a musician has a name and an instrument and, you know, a couple of different pieces of information that you need to store, you know, years of practice or something. All right, so you'll have those types of things. I'll ask you to make me an object that has the correct kind of fields, an appropriate constructor, and then maybe a display method or something like that. So you're gonna have to prove to me you understand how to build your own object types when you need to store specialized kind of data. Make sense? Promise you that's on the exam. Okay, so that's gonna be like your basketball player. That's going to be like our patient record. That's gonna be like our node, those types of things. Well, like our linked list as well. So these different objects did different things. Okay, but the most generic version of those things is basically I need to store data about something, about a basketball player, about a patient record, about a node. A node holds two pieces of information, its value and who the next dude is. Make sense? So definitely be comfortable with that. That's on the exam, 100%. All right, good.
So like a question about what it is or writing one?
Definitely you're gonna have to write one. I might ask questions about what they are. I might write 5 questions to ask it in different ways. But you'll definitely have to write one. You probably will have to read one. I might give you some objects and say, do stuff with these. But 100%, you will have a question that says, given this scenario, create an object with an appropriate constructor and the appropriate getters and setters for this thing. On the exam, 100%. Not even a probably. So study that. Okay? Well, that's good. You like know it'll be on the exam, right? I mean, that's like probably question 1 or 2 or something like that. I mean, it will be there.
Will be for sure musicians.
Huh?
Will be for sure musicians.
It shouldn't matter, right?
Yeah.
But it might be. I mean, that's the example I came up off the top of my head now. And if I forget about that and I try to come up with a different example when I go to write the exam, or I can't come up with a better example, I might just fall back on musicians. Or maybe I'll do M&Ms.
And they have a color.
They have a color, yeah.
And
Religious views.
I was gonna say like age stuff, but you know, if they may be getting old here or something.
How is that less? I mean, what I said is more interesting.
I guess.
I mean, would you eat like a Jewish M&M?
No.
See, now we got to bring Dr. Manouche in here and have like a legitimate discussion about this. Like, have you ever considered the religious views of your candy? Because that takes us down a dark path.
Yeah, we're going to the dark side.
Well, but at what point, when you hit Twizzlers, what are we dealing with here?
Some really twisted stuff.
Pagan rituals, pagan worship. I don't even know. Not biblical, certainly.
Pinatas.
What's this?
Pinatas.
I'm gonna allow it. Doesn't seem like a religion, but we're gonna go with it because Twizzlers they're real.
Yeah.
Yeah, they're real. Okay. Definitely creating your own objects. Now I should just do it for fun. Just, whatever the object is, there's a religious view. It's like, I don't even know what to do with this. Eminem's favorite book of the Bible.
Do we store it as a string?
Huh?
Do we store it?
You would store that as a string, yeah. That's really what I'd be testing. You know, if I said when Eminem has a favorite book of the Bible, it would be a string representation of what their favorite book of the Bible is. Unless you wanted to store the characters in binary. Like that.
I thought you were just gonna have this create a Bible object, like a book of the Bible.
Or we want to keep this biblical, store it as a base 7 number. That's Christian worldview all day long, right?
Don't have a Bible homework this week.
I probably won't put a Bible homework this week since it would be due over break. And I'll have good internet connectivity, but I won't be in the country. Although I do think maybe part of my favorite time of the week is when I read those. Because sometimes you get really interesting, it's like my own little Bible study. Because I'm not a theologian, right? In fact, I was born Jewish, so many of you have been Christians longer than I have. Oh, well, maybe not, because I converted in my teens, but it's plausible, right? Depending on maybe some of my grad students or something. I learned something each week. You just read just kind of an interesting response to something, like, oh, I didn't think about that. That's kind of interesting. And sometimes I'll write little things back, or sometimes I'll just reply with an LOL and make you wonder what I'm replying about. Have any of you gotten the LOL reply? Oh, that's a good one. I just laugh at it. I don't even know why, so I just put LOL. That's my feedback. And it's not that I'm laughing bad. It's just like, that was funny the way you ordered it. So, LOL. And I give him a 20%.
No one said they got the LOL.
What's up?
I thought no one said they got the LOL.
Nobody gives. Anybody have they gotten the 20%? Yeah, usually, I'm not deducting points unless it's late. So that should be free points. So here's all this object stuff. Certainly know what the this keyword is. That goes right hand in hand with creating your own objects as well as using objects. Think about that in terms of like our array list stuff, that this keyword, understanding that is how an object refers to itself from within itself. I don't know how I'll test that, but I will come up with some way to make you prove to me you understand what the this keyword is then. All right. I might look for a way to make you prove that you know what the super keyword is, but that maybe is less. That's less of a priority because we haven't heavily looked at inheritance at this point. I'm really going to focus on creating your own objects on the first exam. So while the super keyword might be used at some point, focus on this. Focus on the this. All right. Singletons will be represented in some way on there, whether I give you one, you write one for something, I ask you what they are. It's a pretty good chance that you would lose points if you were completely oblivious to what a singleton is. That difference between our array adapters, this probably wouldn't come in the form of any more than one question, but just that idea of our built-in array adapter being able to show us collections of strings versus our more complex array adapter that allowed us to have object types where we had to build our own specialized array adapter. So that's kind of an example of inheritance, right? Where my special array adapter, the way we refer to ourselves within ourselves, would be this dot. Whereas super dot is the actual array adapter we are basing ourselves on. Okay, I probably won't focus, like I said, on the super aspect of that, but certainly understand why we created our own specialized array adapter, because we had more complex data than simple strings that we wanted to work with. Make sense? Similarly, why did we override like the myView? Or what was it called? Not myView, the getView. GetView and index. That guy for array adapters, specifically, the job of that dude is to give you a layout that shows what row you're in our case, the list view. Well, it's no longer a simple string in a text view. Now it might be 5 text views or a picture and some stuff. It's how do you want to represent your specialized objects that you're showing. So that's why we overwrote that part of it. Make sense?
Can I have a question?
Nope.
So what do you really mean by overwrites?
Go into here.
Do they have the function before and then you override?
Correct. Yep. But let me just show it to you as a quick example in here. Patient record array adapter.
What's that between add?
This guy right here. So we put the little override thing before, but that was put in for us when we use Android Studio to, we start typing in getView and press enter. The point is that normal array adapters already have this function. Normal array adapters have that function, and what they do is they produce a layout that has a single text view in it and slams a string into it. We needed better than that. We needed more complex than that. So what we did is we grabbed the patient record, We grabbed the more complex version of our layout. In this case, it had 2 text views. And then we set those guys up. And then we returned that layout, that view. Make sense?
So basically saying that you're adding more function to the.
More functionality than we would have had by default. Because the default wasn't enough. It wasn't good enough. So we're saying, look, the default version of getView didn't do what we needed to do. So we're going to override it and write our own. Yep. But important thing here is that this function was already written for us. And if we didn't put it in here, it would not be an error. It just wouldn't be able to handle our data type. And we got that because we extended ArrayAdapter. Make sense? Okay, so that's kind of our inheritance model they've worked with. We haven't written our own inheritance model in here yet, but we've worked with the inheritance model where we said, hey, we like array adapters, whether you liked them or not, you needed them, but we need a better one or a more specialized one. So we inherited from that parent, wrote our own little bit better version of it. We're actually going to write our own even better version of it when we convert this guy to no linked lists instead of an array of patient records, where we're still assuming 1,000 here, right? So we're still saying that's bad, but that's kind of where we're at. But we're ready to flip-flop it now. We have the linked list. We actually have more than the linked list that we need to do this. Because realistically, we actually just needed a linked list that allowed us to add something to the end and get it indexed. We didn't need remove. Well, remove might be handy if we want to start removing elements and stuff, which we're going to do after spring break. We'll start removing stuff from the database, but also removing things from our linked list. We'll probably spend just a couple of classes on that to get this slammed in there. What's up?
If you remove one from the linked list, will it update the database? Or do you
Yeah.
have to call it?
Well, will it update the database or update the array adapter?
Well, I mean, yeah,
Okay, really you're asking both questions, right? If you remove something from the linked list, chances are you removed it from the linked list because we deleted it, which means you probably also want to delete it from the database.
Would you have
It won't do it magically. We're going to have to write that code. So we'll do that after break. It's actually, I'll kind of give you the fair warning now. It's actually very, very simple, and almost all of you will overthink it. It's like one line of code. You just have to keep track. With Firebase, everything's about those database references. We'll talk about that in a second too. But those database references are very important. So if a basketball player knows exactly where he lives inside the database, that is /basketball player /crazy unique key, he can then delete himself. But if he doesn't keep track of that unique key, which we're not currently doing, then he doesn't know actually where he lives. He just knows he's one of those basketball players. Okay? So it'll actually be trivial to delete or update values once we remember exactly where we live by bringing in the key when we fill it up. So I'm just kind of giving you fair warning, almost a hint, that when we go to update or delete stuff in the database, it's like one line trivial, but you're going to overthink it. So just give yourself fair warning for that. Try not to overthink it. It is legitimately trivial, but you're going to sit there and it can't just be that easy. Have you ever done that in code where you something works, it's like, that can't be it. You know what I mean? And then later on, you're like, later on, after I explained it or something, after you've looked at it for a while, you're like, oh, it was it. Now I feel so stupid. Now I know why that was it. Why was I trying to do so much more? I like that in the 200 assignments when students have 7, 8 for loops inside of each other. They just have this aversion to using if statements, so they just put loops everywhere. It's I just don't understand why this works. Actually, that's the worst one. They don't understand why it works, and nobody would understand why this works. It's moons aligning type stuff. Because technically, if your if statement can only ever be true under one condition, you could use loops for every one of your if statements. You would just do a whole bunch of wasting time spinning through stuff, right? But still execute that code one time when it hits. That's an if statement. It's just an if statement with, it's like burning out your tires at the stop sign. Is that what the high school people do? What's it called? Engine braking? They hit the brake and then hit the gas and the tires spin.
It's burnt.
Yeah, burnouts,
Yeah.
burnouts. Yeah, except our modern cars, it's hard to do it with because they have like the anti-slip brakes and stuff like that. So your car won't even let you do it.
Just put it in neutral. I think that works.
Because I wanted to when I was at my house when we had some of the big snowstorms, I didn't want to have to like shovel the giant like piles and stuff. So I just was gonna back my SUV through these different things. I had to like turn all the safety features off in my car. Because my car is like borderline self-driving, so it would like slam on the brakes on me before I hit the hit the snow pile, so I couldn't be destructive. My car wouldn't let me, so I'd like to disable every safety thing, so I was doing donuts in my yard. It was like in a upscale community. You got this idiot doing. I haven't got driving shamed by the Schwan man. Did I tell you about that?
Might have mentioned that.
Yeah, the Schwan man's like the guy who like delivers like frozen food things. So I'm sitting here like knocking down piles of snow in my driveway, but into my yard. I mean, so I'm sliding all over the place, right? Basically just off-roading in my yard. Yeah, this guy drives by, he's like, I was like the human in a car equivalent, like when you let your dog out in the snow. It just starts rolling around. It's like just having a blast. Same thing. My wife was mad too because now stuff's starting to melt. I got all these like ruts in my yard.
Totally working at the moment.
She says I need more adult supervision. All right. So definitely inheritance. The updated version of our ArrayAdapter. Why did we need that? That type of thing. Yeah, so here's, again, an inheritance type thing. I will probably ask some question about inheritance, but I probably wouldn't have you write code related to inheritance. I want you to understand that, in Java and in all modern object-oriented languages, we have a top-level object called object. Sometimes it's a capital O, sometimes it's a lowercase o, but we have a top-level generic representation of an object. And then off that, you might have multiple layers. So like our ArrayAdapter, so here's our patient record ArrayAdapter we wrote in class, which is a normal ArrayAdapter, which happens to be a base adapter that we've never directly used, but it's a starting point for a couple of different adapter types. And all those guys are objects. That's the inheritance model. So understand the purpose of inheritance, that the goal is to not duplicate code that could be used multiple times. So base adapters have some core code in them that could be used for array adapters as well as maybe 3 or 4 other kinds of adapters. So there's the super keyword. Again, I'm going to focus a lot more on this keyword, but it's possible the super keyword makes a appearance. Custom array adapter thing. Same thing, custom list view thing. I might ask something about like creating your own layout and stuff for it, but probably not. That's not really a programming thing. That's how an Android app works thing. So real low priority. I have to be looking for a throwaway question. Definitely database stuff. Purpose of a database. Kind of how Firebase works from a putting in the listener, the value change listener, and that guy gives us a dump of the database when we first start listening, and it lets us listen to various endpoints. So anytime we have a database reference, which takes us to a certain home somewhere in the database, we can choose to say, I'm interested in that. So we can get changes to even a very specific object if we wanted to. We haven't written that yet, but as we kind of go into this, we can say that an object is interested in when somebody else changes something with him directly. And where that could be helpful is, let's say you have 100 patient records. Let's say you're working at a hospital or something like that. Okay, and you have 100 patient records. Well, there might be different nursing stations or something like that might be putting in a new prescription for some patient or something. So I might have my machine open right here, and somebody down the hall updates the patient that I'm also looking at, or that's in my current list, right? I might want all of my individual patient record here, those objects, to kind of keep an eye on their own little data change in the database. So that when there's a change to that one patient record, he updates himself, rather than us getting a dump of all 100 or 1,000, however many patient records I said we had, with that one change in it. Does that make sense? So when that person changes Michael to Mike, something like that, I don't get a dump of 100 patient records that have that one change in it. Instead, only that one object for that one patient gets updated and says something with your specific reference in the database has modified, and here's your new data. So it allows us to be more granular. All right, so those database references are important.
Well, we have to know the difference between SQL and no SQL.
I'd call it really, really, really low priority. I mean, there could be a question kind of dealing with databases at the high level, but because this isn't a database class, I probably wouldn't ask those kind of specific questions. Yeah, so I would say probably not. But certainly understand the purpose of a database of some kind. Lives in the cloud, our stuff doesn't have to live in the cloud, but lives outside of our application and allows us to read and write stuff and potentially ask questions of it and that kind of stuff. Similarly here, these were kind of talking about places we can store databases. I'm probably not going to ask you about things like Heroku and stuff. These are all important industry standard tools. Heroku is really popular for web applications and even mobile applications, but not, on any of my exams, always think about what is the core competence of that class. So even if I've covered some material that are related to it, when I'm testing you on our learning outcomes for that class. Okay, so you knowing what Heroku isn't an important learning outcome of 300. 300 is a programming data structures and integrating database into code stuff course, right? If you were in Dr. Wall's 430 database class, now that question about SQL versus no SQL, that's right in the wheelhouse, right? So whole different thing. So I'm trying to give you that bigger world view of where these things live, but when I test you, I'm going to test you on the things that are specifically related to the learning outcomes for the class. Same thing with Firebase. I mean, when our databases are Firebase, but I'm not going to ask you specific stuff about Firebase. Having said that, there is something important for the way we're solving problems with this idea of a real-time database. So I won't ask you what a real-time database is, but understand that whenever there's a change to the database, we immediately become notified of it if we've set up a value listener, value change listener. Similarly, we should definitely know what JSON is. Firebase is not the only kid in town storing stuff as JSON. JSON is a data format, JavaScript object notation, but know what that is. If I ask you, for example, to write a line of JSON that is a representation of maybe some object that you've created. So, here's your basketball player, Mike Littman with jersey number or something. Write a line of JSON that's equivalent as a representation of that player. So you should be able to show me what JSON looks like. Well, JSON is name value pairs. So if you had if it was a basketball player, it would look like this. You might have first name, Mike, L name, Littman, jersey num 30, something like that. And this should have double quotes around it, although it actually doesn't matter. JSON will work with either. So that would be a JSON representation of a basketball player that holds 3 pieces of information. Name value pairs.
Do we need to start into like an object, something like, for example, something.
No, this is just, if I say write the JSON, this is what the JSON is.
Okay.
Yeah, JSON is a string representation of objects. You know, if I asked you to do something with the JSON, then something else might come alive. But maybe, you know, as we're kind of getting farther into this, you certainly should know what serializable means. What do we need to do to an object to make sure it can be stored and retrieved from Firebase? So make all your fields public. And also, you must have a no argument constructor. I might also ask, why do you need a no argument constructor? Since all your fields are public, when you go to read an object back from the database, it's going to create a blank version of your object, then set the individual public fields to those values. It's not going to know what your special constructor is that takes first name, last name, jersey number. Instead, it's just going to say, here's a blank basketball player. Set that dude's dot first name to this, dot last name equal to this, dot jersey number equal to this. And it can rely on those because those fields were public. Make sense? So know what it takes to be able to read and write things from the database in Firebase. You know, you won't have to know anything about Microsoft Azure or web services. I was just kind of talking about here's the competitors to Firebase. Same thing with cloud computing platforms. Although this idea of IaaS and PaaS, I won't directly test you on it, but those are acronyms that you should be familiar with for industry. You'll want to know if somebody says, here's a cloud computing platform that's IaaS, then you know, okay, I'm going to have to do a lot of the work myself. They're giving me an infrastructure, I'm going to have to reinvent all the wheels, because they have a lot of flexibility, versus platform as a service, PaaS, it's saying, hey, here's the way you do it. Firebase is one of those. If you want to talk to the Firebase database, we have our little Firebase assistant and says, click this, click this, click this, and now we're talking to Firebase. There's only one way to accomplish it. And then we had to fix it because their way was broken. Which seems kind of ridiculous given that the same company makes both sides, isn't it? I mean, Android Studio is made by Google. Firebase has been owned by Google for, this isn't like 2 weeks long. I mean, this is multiple years now. Shouldn't those two seamlessly talk to each other without errors? Like right off the bat? Where we actually had error, we had unique errors. We had errors on the Mac side that didn't exist on the Windows side. And then we had Windows errors that didn't exist on the Mac side. Big fun. Big fun. Okay, so certainly understand the role of a database in our applications. The concept of an interface, we talked about interfaces in terms of serializable, and I also used runnable as an example, so anything with an able at the end of it. And that interface basically says if you're going to implement an interface, you are agreeing to do all the things that make you compatible with things that understand that interface. So serializable says make your fields public, make a no argument constructor, at least serializable from a Firebase perspective. Runnable says you must have a public void run function. All right. I'm not going to ask you about runnable as a specific thing. I'm just giving that as an example that if you were to write something that implements runnable, the runnable interface demands that you write your own run function. And if you don't, it will scream at you. Because when you said, I'm implementing runnable, you've agreed to write that function. That's the job of an interface, is to police your code and make sure that what you're writing is compatible with whatever else you're doing in your program is demanding. Firebase demands your objects be serializable. If you're working with threads, which we haven't done yet, but as an example, it demands that your underlying code must have a run method because that's what thread will call. It'll assume you have a run method.
Do you know there's a time that you like delete all the override thing because of the database? So is that under the serializable too?
What do you mean delete the override thing?
Like when you get H or whatever, and you said that the database will not read it, so you delete all the override.
Oh, it would delete the, well, we could have gotten rid of the overrides. We actually don't have to do that in the current version of Firebase. Current version of Firebase, as long as your fields are public and you have a no argument constructor, it'll work.
Okay.
Historically, you had to put in a field, kind of placeholder thing called exclude that said exclude this, exclude this, exclude this, but now the way it processes your files, I mean, it was never storing the functions before anyways, but it used to get confused by functions. The latest version, as far as I can tell, doesn't care about that. Oh, I'm pushing the wrong button. I'm like, haven't we already seen these? I was going back in time there. All right, so the whole serializable thing, working with the data, the whole serialize versus deserialize. If we're writing to JSON, we serialize their data. If we're reading from JSON, we're deserializing. Or writing to Firebase, we serialize it. If we read from Firebase, we're deserializing it. The observer design pattern, as it relates to our value event listeners, where we've seen it, right? We're saying, I want you to yell at me when something's changed with this reference. Certainly patterns of communication, synchronous versus asynchronous, where value event listener is an asynchronous example. It's non-blocking. So we can say, hey, pay attention to changes in the database. I'm going to move on with life. That's asynchronous. Synchronous says, ask the user for some information, sit there and wait patiently until they finally type something in and press enter. That code blocks, keeps us from progressing. That would be a synchronous example.
What is the situation that you are like forced to using a synchronous?
Well, there's not a force or I mean, I guess forced to use asynchronous would say that you legitimately can't move on with your program until you have this information. You can't convert a number to binary if you don't have the number yet. So you have to ask the user, please give me a number you want me to convert to binary. You can't just move on with life and start converting unless the user's given you that number. So you have to wait for that number. Talked about context stuff, the data snapshot stuff. This is all stuff we're getting crap from Firebase. Fields and objects, and then the linked list stuff that we've done more recently. So you will probably have to do something with linked lists, either read them, write some aspect of them, answer questions about them versus arrays, that kind of stuff. Got it? Okay, 10 questions, the usual exam. You have, huh?
Do you have conversion?
There'll almost always be a conversion question on my exam, so that's just a given.
So what type of conversion is?
I don't know.
It's going to be something decimal.
Yeah.
Yes.
Probably numeric, like binary to octal or something like that, but
Because
any,
there's one time it-
anything's fair game. I should be able to ask you what 20 megabits per second is in,
How do you convert that in IE?
that's the whole 1024 chart.
No, like per second.
Well, don't worry about the second thing. If I ask you what 20 megabits is in gigabytes, you should be able to do that conversion. All right, I'll see everybody on Thursday. Today, student, faculty, staff, Bible study, God and Grub. Go to the cafeteria, sign in, get your free lunch, take it down to the terrace room from noon to 1.
Okay, question quick. What is the benefit